to solve another Leetcode problem. 298 binary tree longest consecutive sequence. So for this problem, we are given a binary tree, and inside it's going to be positive integers, and we want to find the longest consecutive sequence. So for example, 3, 4, 5, this is going to be the longest sequence. So we're going to return a 3. Yeah. So a consecutive sequence path is a path where the value increase by 1 along the path. Yeah. How can we solve this problem easily? Definitely we cannot solve it by using n squared time. We have to use it by O(n) time complexity. Yeah, because this n is 10 to the power 4. If we are going to solve a tree problem by using O(n) time, basically the best way is post-order traversal. Yeah, normally there are going to be 3 different kind of traversals: pre-order traversal, in-order traversal, and post-order traversal. And for this problem, yeah, it's going to be easier to be done by post-order traversal. Let's just have a very simple example. So for example, we have a node of 1. At the right side, it's going to be a node 3. At the right side, it's going to be a node 2. The left side is going to be a node 3. So currently we are traversing this node 1. So if we are traversing this node 1, what about if we already know the result for the left subtree and the result of the right subtree? So what do I mean by that? Yeah, so before I'm checking this node 1, I've already know what is the longest consecutive consecutive path for the left subtree, because there's only one node, so it is 1. For the right side, for the left side, it is also similar, it is 1. Now we're going to check our current node. So because this is 1, 1 plus 1 equal to 2, so this means the final result is going to be 1 plus 1. So it's going to be a 2. So here it's going to be like 0 plus 1. Yeah. So final result is going to be maximum of the 2. So this means the final result is going to be 2. Yeah. Now the problem comes, how can we calculate this one? Because the tree is basically a recursive function. Currently, if we know how to calculate this 1 plus 1 equal to 2, definitely we're going to know how we can calculate this 2 plus 1 going to equal to 3, 3 plus 1 going to equal to 4, because this is basically recursive function. This is exactly what we are doing. So the post-order traversal is, while we are checking this node, we already know the left side and the right side. We just need to choose the maximum of the final result. Yeah. Now let's just use this post-order traversal idea to solve the problem. So inside it's going to be a node. So if not a node, so we're going to return a 0. So basically it means there's no node. Definitely we're going to need a return. It's going to be 0. Now we're going to prepare the left side and the right side. So this L and R means what's going to be the longest sequence, a consecutive sequence of the left subtree. What's going to be the longest subsequence of the right subtree? Yeah. So here not dot left and DFS not dot right. Yeah. Finally, we're going to prepare an answer to be 1, because currently if we have a node, current node, so it means we have a path, it's going to be 1, and then it's going to be 2. Yeah, because here the path is just the number of consecutive nodes, so we're going to prepare an answer as 1. Finally, we're going to return the answer. Now let's just check how we're going to call this DFS function. So we're going to prepare self.result to be 0, and then we're going to call the DFS, and finally we're going to return self.result. Yeah. Now what are we going to do? We need to check our main functions, but how can we check? So if not dot left side exists and not dot value plus 1 equal to not dot left, so basically we're going to update the answer. Yeah, so the answer is going to be here. Let me put it here. Yeah, above it. So the answer is going to be the maximum of the answer with this left side plus 1. And similarly, yeah, we just copy the same code and change it to right. Yeah, because basically for tree, it is symmetric. Yeah, it is symmetric, so we can just copy and paste and change it to right. And here, this is going to be R plus 1. Yeah, before we get to the final answer, we need to update the result, because the result is going to be the self.result with the answer. Yeah, because currently, actually, like the post-order traversal, we are checking each node. but the answer is not at the final node. The answer is just in between. That is why we're gonna prepare a global variable self.result. We just choose the maximum value in between the loop, in between the recursive function. Basically, it is the on time. Yeah. Now let me just run it. It didn't work. Let me check why it didn't work. So this is the not dot left and not dot right. Answer gonna be 1 is not dot left and not dot value plus 1 gonna equal to not dot left dot value. So this is why, because I didn't write the right code. It's gonna be the value. Otherwise, how can I compare? Yeah. Now let me just run it and submit it to check if it works. Now as you can see, it passes for all testing cases, and the time complexity is ON, because this is a post-order traversal. Before we are getting the value, yeah, this LR is already calculated before we are calculating it. This means first left traversal and then right, and then I gonna go to the current node. So this is exactly the post-order traversal. Thank you for watching. See you next time.